Hi folks, it's Mr. Robeson here. Today we're going to talk about standard deviations. This is the last section in Unit 2 for us. Standard deviations, we're going to look at populations versus samples, how to calculate standard deviation, mostly on Google Sheets, the concepts of standard deviation, and how to tell standard deviation from graphs. All right, so the standard deviation is the average distance between data values and the mean. So again, the average distance between the data values and the mean. And we have two symbols that we use for mean, either x bar or mu. So x bar is for samples, mu is for populations. Right? It doesn't make much of a difference. And we have two symbols for standard deviation. S is what we're usually going to use for samples. Sigma here, sigma, is what we use for populations. All right? So standard deviation is a measure of spread. So we've talked about range before, we've talked about IQR. Now we have standard deviation as another measure of spread. And standard deviation, it has two formulas, one for samples and another for populations. All right, now we don't have to memorize these formulas. They're built into Google Sheets. They're also built into most of the graphing calculators. So we can just use that. We just have to know which one is the one to use and when to use each one. So if we're working with a sample, we're using the letter S and we're using the sample formula. If we're working with populations, we're using the letter sigma. All right, so for sample, we just use equals standard dev or equals standard dev s dot s. For populations, it's equals standard dev dot p, p for population. All right, we'll take a look at that in a minute, how to do it in actual Google Sheets. All right, so here's just a little organization. So remember, samples are the small groups from the population. Usually we're working with samples. So usually most of the time we will work with samples. Populations is if we have everybody in the group that we're interested in studying. So all members of the group, that would be a population. Notice the word all there. Here's the formulas again for sheets. Standard dev for sample, standard dev dot p for population. And the formulas again for sample versus population. So let's compare how they work in Google Sheets. All right, so here's a data set. So I just put in a list of numbers. And if I want to find the sample standard deviation, see, I wrote it out already. So I'm just going to type equals STDEV. See, there it is as an actual function. It doesn't matter if it's capital or not. We put our parentheses, and now it says select a range. So I'm just going to click at my top cell and hold till I get all of them, unclick, and my cursor's still there, so I just close parentheses, and it's even giving me a preview of what it's going to be, 5.17, and I just press enter. There's my standard deviation. All right, so this was for a sample. So if this was just a sample of data, that would be our answer. All right, but what if it's the population? So then I'm going to put equals, I'm going to type STDEV dot P, and it even says standard deviation of an entire population. Yep, that's what I want. So parentheses, and you can click from the top or the bottom, it really doesn't matter. There we go. Highlighted that section, and it gives us the preview 4.96. So they're pretty close to each other, and the more numbers you have, like the closer they're going to get, because this one's dividing by n minus 1, this one's dividing by n. That's the big difference between the two, and that's really the only difference between the two. So they're both pretty close to 5. All right, so hopefully you can do that now, and you'll have to do that on the homework for practice. All right, so some concepts about standard deviation. So standard deviation is always greater than or equal to 0. All right, so it's never negative. It's always got to be greater than or equal to 0. The only time it can equal 0 if all the data values are exactly the same, like 1, 1, 1, 1, 1. If they were all the same, then our standard deviation would be 0 because none of them deviate from the mean. All right. If even one of them is different, 1, 1, 1, 1, and 2, then our standard deviation will be greater than 0 because now they will deviate from whatever the mean is. Here the mean was just 1. Here the mean will not be equal to 1. It'll be somewhere between 1 and 2, and all of them will have a little bit of what we call deviation from the mean. If we have outliers, they make our standard deviation get much larger. So outliers cause standard deviation to change a lot, just like outliers affect the mean. And the farther data values are from the mean, the greater the standard deviation will be. All right, so here's a little exercise. So put the data sets in order from smallest standard deviation. So we're starting from smallest and we're going to largest standard deviation. So a hint for each one of these sets, every single one of these sets has a mean of 5. All right, so I made them this way that all of them should have a mean. Well, maybe this one doesn't quite. Maybe if this was a 4 instead of a 3, that would work. This one definitely has a mean of 5. That's 10 and 10, so this has a mean of 5. And this was supposed to be a 4, I believe. Yep, I just mixed up those two. All right. I'll fix it before I post it online. All right, so now which one has the greatest, which one has the smallest? So the smallest is, all the numbers are the same here. So this guy has a standard deviation equal to 0. So C is definitely the smallest. So I'm going to start with the smallest. And that will be C. And let's see, the other end will be the largest. All right, so now the largest one is actually the second easiest one to find, is this guy. It's A, because all of these guys are at the very end. So all of them are 5 units away from 5. So this guy, A, is going to have the largest standard deviation. Now we say, okay, well, what's the next smallest? Which ones are next closest together? So we've got 0, 4, 6, and 10. 0 and 10 are pretty far away from 5. 3, 4, 6, and 7. Well, it doesn't have any 0 and 10, so this is definitely smaller than this guy. 2, 4, 6, 7. Well, the 4s and the 6s will have the same deviation. The 2 is going to be more than the 3. Oops. And the 7 is going to be less than the 8. So D is actually going to be the smaller one out of these guys. Why is my pen not working? No, because it won't work. So the next one is going to be... All right, so the next one will be D. So D is the next smallest. Nope, still doesn't want to work, but now it does. This is annoying. D. All right, so D is next. All right, C is just a little bit bigger than D, and the 0 is farther away than the 2. The 10 is farther away than the 8. So next up is going to be E, then the next closest, and finally B are the next closest after that. So there we go. There's our order. So it's going to be C, D, E, B, and then A is the farthest away because they're all far away from 5. And these guys are all 5. These guys are close to 5. These guys are fairly close to 5. And these guys are, well, some of them are close, some of them are far. All right, put the graphs in order from smallest standard deviation to largest. So now we're doing it from graphs. All right, so the smallest standard deviation will have all the values close to the mean, and the largest will have them all far away. So here's a hint. All of these guys have a mean right here in the middle at 4. All right, so all of these are symmetric data sets. All of them have a mean at 4. All right, so let's see, smallest. And then we got next, next, and then largest. All right, so if you wanted to, you can put the numbers into Google Sheets and just do it from that. You could, that would work. You could also do it just by looking at it. So the easiest one to probably figure out is the largest, because all of these guys are as far as possible away in data set A. All right, the farthest we get for any of them is 1, and the farthest we get above for any of them is 7. So the largest standard deviation is going to be A. The smallest, we want the closest numbers to it. So let's see, set C has 4 numbers that are different from the mean. Set D also has 4 numbers. Let's see, these guys are 1 away. These guys are 1 away. But these guys are a lot more than 1 away. And these guys are only 1 away again. So set C is probably going to be the smallest. All right, next up, let's see. We got the same distance away for B here for these first 2 that we did for these 2. And we have the same distance away for these ones as we did for these ones. Maybe I'll double mark them to see. All right, but that's all the deviation from D. B also has these extra guys in here. All right, so B is going to have a bigger standard deviation than D. So the next smallest is going to be D and then B. All right, now if you didn't like this, you could just put the numbers, you could like list out the numbers. Say this is 1, 1, 1, 7, 7, 7, and you could put that into Google Sheets and get your standard deviation. All right, and this would be 1, 2, 3, 4, 5, 6, 7. Throw those numbers in Google Sheets, get your standard deviation. That works perfectly fine too. All right, so that's all we need to know for standard deviation for now. We'll work with it more when we get to some other distributions, normal distributions and z-scores. But right now, if you can calculate it and you kind of have an idea of how it works with a set of numbers and with some graphs, you should be good to go to get through this section. All right?